All right, so we're looking at actually using the ideas that we talked about. Well, you talked about last year, but we just reviewed in the previous idea. Um, so we're going to use the rules, or we're going to actually, instead of calling them rules, we're going to actually call them theorems instead. So our theorems are like hardened rules that we have in mathematics. So remember, our alternating interior angles are always congruent if they're parallel. That kind of stuff. We're going to use those rules within this to help us with these ideas. So what I want you guys to be able to do is to be able to take a diagram like what we talked about before, and not just look at these lines, line L and M and T. But I want you to be able to tell me what can show us, or what can prove to us that L and M are parallel. So, for example, again, if I have angle 1, 2, 3, 4, 5, 6, 7, and 8, if I have these angles that I'm using here, what would guarantee that these two lines are parallel? Because not everything guarantees, like, just because, like, let's say 1 and 2 are congruent to each other, that doesn't prove that L and M. Okay, so it's the right information. So let's say we had angle 4 is, let's say, congruent to angle 6. Is that enough information to say yes, L and M are parallel? That's what we're looking for. So the question is, if this is true, if angle L is congruent to angle 6, or sorry, angle 4 is congruent to angle 6, is that enough information to show, or for us to know that L and M are parallel to each other? And the answer to that question is yes. So this is absolutely true, because angle angle 4 and 6, they're alternating interior angles, and they are congruent. And so that means that, so this means that line L is parallel to M. Okay? But we've got to know that it's got to be that they're alternating interior angles and they're congruent. Okay? If it's not, then we can't have that. So that's the idea of this. We're using our rules to show that L and M are parallel. That's what we're trying to get to every single time. Okay? So let me pose this. If I told you the following information, would it be enough to show that the L and M are parallel? Okay? So if I said, hey, I've got line, or I've got angle 2 is congruent to angle 8. Is that enough information? So the question is a yes or no question. Is this enough information for us to show that L and M are parallel to each other? And the answer to that would be yes. Again, we have alternating exterior angles, and they're congruent. The symbol for congruent is this little squiggle with the equal sign underneath it, which I've just ruined by trying to write it twice. So, okay. Again, let's continue with this. What's the right information? So let's go here. Let's say that angle 1 is congruent to angle 3. Is that enough information to show that L and M are parallel? And the answer to that is no. This is a true statement. 1 and 3 are going to be parallel to each other, but they're vertical angles, and vertical angles are always that. If you guys remember from the previous idea, it's the 1 and 3 are always parallel, just because, or always congruent, because they are vertical angles. But it does nothing, or tells us nothing, about whether these lines are parallel or not. Okay? So again, continuing with this, let's say we had angle 3 is supplementary to angle 6. Is that enough information? So 3 and 6 are supplementary. Well, 3 and 6 are what's their relation they have. Those are consecutive interior angles. And again, if you remember from the previous consecutive interior angles, when these two lines are parallel, they're supplementary. So if I go the opposite way, I'm just logically thinking the opposite way. If these are consecutive interior angles and they're supplementary, that means that these two lines, L and M, have to be parallel. It's just a given at that point in time. Okay. Let's do another one here. Let's see. We've got angle 8 is supplementary to angle 7. So 8 and 7. Does that mean, or does that show, or tell us that L and M are parallel? So 7 and 8 are linear pairs. And again, linear pairs do not show that they're parallel. Linear pairs are always supplementary. So this would be no. It does not show that those two lines are parallel. Okay. So it has to be one of those 4 rules. It has to be alternating interior angles that are congruent. It has to be alternating exterior angles that are congruent. It has to be consecutive interior angles are supplementary, or it has to be corresponding angles. One of those has to be that shows that those lines are parallel. Okay. Let's look at another idea here. So, well, similar idea. So we've got our parallel lines here. And we've got our transversal here. We'll go the other direction with this one. What if I had this angle up here? Let's say we don't have an angle, but let's just say this angle is like x plus, let's say 30 here. And then this angle down here, let's say it's 2x minus 40. And I want to know what's gonna make L and M parallel. So I want to know what value x has to be to guarantee that L and M are parallel. So what does x need, or what's the value of x need to be for L to be parallel to M? That's the question here. So again, I go through my logical process here. I say, well, how do those two angles relate to each other? And I've got this angle up here, and I've got this angle down here, and they're not numbered anymore. But look at what position they're at. This is an exterior angle, this is an exterior angle, and they're alternating. So these are alternating exterior angles, which means they have to be congruent for these two lines to be parallel. Again, that's one of my rules. In order for these two lines to be parallel, these have to be congruent. So what I want to know is when does 2x minus 40 equal? When is it equal to x plus 30? So the nice thing, again, I can write out this statement. When does 2x minus 40 equal x plus 30? I want that to be true for these to be parallel. And that'll show me what value of x is. So if I want value of x, instead of guessing checking, I can just solve this, guys. So let's just solve this. I'd minus this x over. So I'd have x here, and then I'd plus the 40 over. And so I'd have x equals 70. That means that x has to be 70 at that point in time. Otherwise, we are not going to be equal to each other, or we're not going to be parallel to each other. This is the value that would guarantee those two lines to be parallel. Okay, let's look at another one of those. Okay, let's go this way here. And go here. Okay, let's say we had this that was x minus 10, and let's say we have this angle down here, which is 3x plus, let's say, 80. So again, I'm just going to identify what type of angles there are. Again, I'm trying to get L and M to be the same. I want to know what value of X it has to be. Well, these are alternating interior angles. So again, alternating interior angles. And they have to be congruent. So what I need to do is say, okay, well, if they're congruent, that means what, so x minus 10 has to be equal to 3x plus 80 for them to be parallel for us to guarantee. So I can, again, solve this. I can minus the x over here and get 2x minus the 80 and get negative 90, and then divide by 2. And so I'd have x has to be equal to negative 45 at that point in time, okay? Which, again, when you start making up your own values, that's what that ends up having. You have some values that kind of make it funky at that point in time. So, okay, so that's that right there. Let's do another one of those. Again, I'm just throwing values out here. Those are parallel. Well, maybe, I don't know. We'll see. Huh? We want to, again, make L and M parallel. So let's go with this value here that is 2x minus 1. And let's say we've got this one, which is 3x plus 5 here. And again, I want to know what does x need to be to guarantee L and M are parallel. Well, again, I just go through it. What type of angles are this angle and this angle that's here? Those are consecutive interior angles. So those are consecutive interior, and they have to be supplementary. So this is not equal to each other. So just don't get tearing. I mean, make sure you know what's going on. Which that means that 2x minus 1 added to 3x plus 5 has to equal 180 degrees. So that's how we're actually going to show that those two are. So I'm just going to combine my like terms. 2x and 3x gives me 5x. Negative 1 and 5 give me 4. And that has to be equal to 180. I can just go about solving this. I can subtract, obviously I can subtract that 4 over and then divide by 5. And so I'm going to go minus 4, which that gives me 176. And I've got 5x here, and then divide by 5, and x is going to give me 35.2. That's what x would have to be to guarantee that those lines are parallel. Again, our goal is always to show or prove that, or what do I need to have happen for them to be parallel, okay? So just a quick recap, we talked about this, what would make these lines parallel? Well, just some general statements, and then we talked about it, what does x have to be to guarantee that these are. So it's got to be one of those 4 rules, guys. Alternating interior angles have to be congruent, alternating exterior angles have to be congruent, corresponding angles have to be congruent, or our consecutive interior angles have to be supplementary. It's got to be one of those 4 for those lines to be parallel. Okay, math moment with Mummy, out.